All right, so this is 7-7 notes, which is find a particular solution. So the general solutions have a C in them. But if you look at this problem, they give us a point on each one of these, and we're going to be able to use the point they give us, which in this case is right here. We're going to be able to use that to find the exact solution or value for C. Okay, so my whole goal here is to, again, I'm going to do the same thing. I'm going to get all my x's on the right side, all my y's on the left side, and then I'm going to do an integral, plug in my number, find C, and then solve this whole thing for the equation y. So if you look, I've got an x squared plus y squared on the left side and x on the right side. Now my dy is on the top on the left, so I got to keep my y's on the left side. So what I want to do is I'm going to divide each side by y, or multiply by 1 over y, so that my y's are all over here on the left side. I've already got this x over here on the right side, and I need to divide by x squared plus 4 to get it over there on the x side, and then the dx on the bottom has to be multiplied over. So now I'm going to do the integral on both sides so that I can get my equation. So on the left side, I'm going to have the natural log of the absolute value of y equals, now over here I've got to do u substitution. So I'm going to let u be the denominator, and then du is going to equal 2x dx. So as you can see, we have the x, but we need to create a 2 and destroy a 2. So over here, I'm going to have 1/2 the integral 1 over u du. So when I do the integral of 1 over u du, I got 1/2. I got the natural log of the absolute value of u, but I'm going to stick my x squared plus 4 back in there. And I've got some plus c out here. So now what I want to do is I want to simplify both these things first, and I'm going to get rid of the natural log stuff, and then we're going to plug in our point, -3, 2. So first of all, I got to take this half that's out here in front, and I got to move it to the power. So I'm going to do that right here, and then that's going to get rid of this part down here. So I got that up to the half. So that means x squared plus 4 is in a radical, if I want to think of it that way. And then I'm going to take e, oops, I'm on the wrong button here. So I'm going to take e to this side and e to this side, which they cancel out with the natural log. So I'm going to get y equals, and then over here, I've got the square root of x squared plus 4. And this e here, if you remember, we talked about this the other day. If I have x squared plus 3, that's the same as x squared times x cubed. So this e also comes down here to this. So it's actually e to this thing times e to the c. Well, this whole thing is a brand new c. And we're going to stick that c in front of the radical. And now I'm going to plug in my point and be able to solve for c. So when I plug in here, and I'm going to kind of do it in the problem. So I'm going to plug in -3 for my x right here. And over here, I'm going to plug in my 2. And -3 squared is 9. And 9 plus 4 is radical 13. So c is going to equal the 2 on the left side divided by the radical 13. So again, you can have radicals in the bottom. So this equation, the answer to this equation, is going to be y equals, and you plug your c into in front of the radical. So it'd be 2 over radical 13, and then times the square root of x squared plus 4. So that would be the particular solution. In other words, the exact solution in number 3. Now we're going to do the same thing on the other two problems, and we'll be done with the notes. So here we go again. Okay, so first of all, what I notice here is I've got my dx and my dy are on the same side. Well, I got to get one on one side and one on the other. So I think because dy is normally on the left, I'm going to subtract this whole thing right here over to the other side. So I'm going to have e to the negative x squared times y squared minus 1 dy. And then when I subtract that thing over there, I'm going to get minus xy dx. So now I still have to separate all my x's from one side to the other side. So, and my y's on the other side. So my dy's here, so all my y's are on the left, my dx is there, so all my x's are going to go on the right. So this y that's over here with the negative x dx, I'm going to divide it over with the other y. So I got y squared minus 1. I'm going to divide by y all over y dy. So I got that look right there. And then I'm going to divide by e to the negative x because I need that over here with this. So this is going to be e negative x and then e over negative x squared dx. Now on the left side, I have a monomial. So I would need to split that up into two denominators, which I'm going to do right now, hopefully. Okay, so let's see, we got this minus here, and then I'm going to have a y under here and a y under there. So then I'm going to have this y squared over y right here, and I'm going to reduce this because I don't have much room. So that y squared over y is going to make that just a regular old y right here, if I can get this to right. There we go. I'm going to integrate this whole side. And then over here, I would probably take this negative exponent. I think I'm going to move that up to the top with the negative x. So I'm going to rewrite this side over here. So this side over here is going to be negative x e to the positive x squared. And then I'm going to integrate this side over here as well. So when I integrate y, I get y squared over 2 minus, and this is 1 over y, so this is minus natural log of y. Okay, and then on over here, I'm going to do u substitution, and u is going to be x squared. So du is going to be 2x dx. So again, I'm going to have to create a 2 and destroy a 2. And so what that's going to give me is negative 1/2 integral e to the u du. Okay, so I'm going to come over here and I'm going to do the integral of e to the u du, and I'm going to erase this thing right here so that I got room to work this out. Okay, so I've still got over here, I've got y squared over 2 minus natural log of y. And let's see, over here I'm going to have negative 1/2 e to the u plus some c. Well, so I'm going to put plus c here. And then I'm going to stick in my u. Again, my u was x squared. So up there where that u is, I'm going to erase this u and stick x squared back up there. Okay, so there's my problem. Now, what I got to do now is plug in my point. Well, they gave me the point 0, 1. So that means I'm going to plug 0 in for x. Okay, so I'm going to do that with a different color. Make it blue. So I'm going to stick 0 in right here. And then I'm supposed to stick in 1 for y. So I'm going to stick a 1 here and 1 here. So this is going to give me 1/2. And then this is 0. This whole thing's 0, so I'm not going to write it in there. And then over here, I've got negative 1/2 times e to the 0, which is 1 plus c. So I'm going to add a half over, so c is equal to 1. Okay, so now I'm going to And this is right here is where I plugged in. Right here is where I plugged in my values, my 0, 1 point. So that's where I got to plug that 1 in, is for that C. So I'm going to erase all this stuff over here. Okay, almost done. There we go. So then I'm going to have y squared over 2 minus the natural log of y is going to equal negative 1/2 e to the x squared plus 1. Now I'm supposed to try to solve this for y, but it doesn't look like this is going to solve very easily. So I would probably multiply both sides by 2. Just to get rid of that fraction there. And I'm going to get y squared minus 2 natural log of y is going to equal a negative e to the x squared plus 2. When I multiply each side by 2, that'll at least get rid of my fraction. And it really doesn't look like I can solve that very easily for more stuff, so I'm going to go on so this video is not too long. So we're going to do one more problem here, and then we'll be done with 7-7. So I'm going to do the same thing, and if you notice, this says has a slope, which sometimes they put it like that, but not very often. So what that means is dy dx is a derivative, because has a slope means that's a derivative. And that's y over x squared. So there's the equation that I need to do my separation of variables. I'm going to plug that 1, 3 point in later. So again, I got to get my y's on the left side. So I multiply each side by 1 over y, or divide by y. And then over here, I've got 1 over x squared, and I multiply the dx over. So I'm going to integrate and integrate. Okay. So on the left side, I'm going to get the natural log of the absolute value of y. But on the right side, that's x to the negative 2 power. So I'm going to rewrite this, because it's not a regular old x. I've got to bring that x up to the top. And then I'm going to add 1 to the power, which is x to the negative 1, which we'll put that underneath all over negative 1, which makes that negative 1 plus c. And then I'm going to e both sides, because I want to get rid of that natural log. So this is going to be y equals, and again, just like before, this is times e to the c. You can get rid of that plus sign, and then this right here is a brand new c, which we're going to put in front here. So it's going to be ce to the negative 1 over x. And then I'm going to plug my 1, 3 in. So I'm going to get 3, because that goes in for y, is going to equal ce, and then my x is 1. So that's going to be negative 1 over 1, which is negative 1. So we're going to divide each side by e to the negative 1, which bring that negative 1 up to the top makes my c 3e to the first. So then this is where I plugged them in. So that's what my equation is going to be. So it's going to be y equals 3 over e to the, sorry, that'd be a 3e, not, sorry. Okay, so it's going to be 3e. This thing right here is what I'm putting in for that c down here. And then it's e to the times e to the negative 1 power. Negative 1 over x power, like that. That's e to the first times e to the negative 1. And again, those are like bases, so you're allowed to add those exponents. So this is probably how they would write the answer right here. This is your particular solution. So that's the end of that. I will see you in class 6.